Okay. After you take the unit test this week, you're starting Unit 5. Unit 5 deals with trigonometry. Trigonometry is a thing in math, a study in math, where we start using the angles in a right triangle. So we're going to be dealing with right triangles all the time, right triangles. And I'm going to tell you that the side opposite that right angle is always called the hypotenuse. We always know that one is the hypotenuse. If I'm looking at this angle up here, this side here is the adjacent side, and this one is the opposite side of that angle. It's just a way of looking, of identifying what angles I'm talking about. And we're going to have three functions that we deal with. We deal with the sine function, we're going to deal with the cosine function, and we're going to deal with the tangent function. And if I'm taking the sine of an angle, that's what I'm doing, is I'm going to take the sine of an angle. It's going to be equal to the opposite side divided by the hypotenuse. If I'm going to take the cosine of that angle, it's going to be equal to the adjacent side divided by the hypotenuse. And if I take the tangent of that angle, it's going to be equal to the opposite divided by the adjacent. Now, is this something that's rocket science that no one has ever used before? Well, I'm just going to go over here real quickly and application share the calculator again. Okay? Why am I doing that? Because look right here. There's a function. Sine. There's cosine. There's tangent. We have those available to us on our calculator. I'm going to show you a couple things about this one. If you go into the mode of a calculator, up here at the top where it says radians and degrees, we're talking about angle measurements. We're talking about degrees. If you don't change that to say degrees, like that, you will not be getting the right answers. Okay? But if I take a 30-degree angle and I say, well, what's the sine of a 30-degree angle? It will come back and tell me the sine of that 30-degree angle. And if I have a 60-degree angle and I take the tangent of a 60-degree angle, it will come back and it will tell me, the calculator will tell me the sine of that 60-degree angle. So your calculator is going to be your friend in this one, because quite honestly, you're not going to memorize all these different values. But you need to know how they're calculated, because that's where you're going to see the problems and how you're going to see the problems. Now, you have to memorize that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. One way of doing that is by remembering SOHCAHTOA. Mr. Greene, what is that? Well, that's an Indian name. SOHCAHTOA. And where does it come from? Sine is the opposite over the hypotenuse. See that? Sine, opposite over the hypotenuse. The cosine, the adjacent over the hypotenuse. Cosine, adjacent over the hypotenuse. Tangent, opposite over the adjacent. Opposite over the adjacent. If you don't want to memorize this one, there are others. Mine that I memorized when I was in high school was that Oscar and Oliver have had algebra, and that was the sine, cosine, and the tangent. Okay? That's the way I had to memorize it. But I have had other people who have used other ones. I've had some old horse caught another horse taking oats away. Any acronym that you can use to help you remember how these things are put together, you will use that information over and over and over again. Let me give you a couple examples. Here are two triangles, okay? The relationship between A and B, AB, this side down here, and AC, this one over here, 9 and 12. Well, that's 9 divided by 12, right? Look at the relationship between this one over here, DE That's 3 divided by 4. Guess what? These work out to be the same values, don't they? 3 over 4. They're exactly the same. You shouldn't have any problems with that. That means right triangles are similar to each other. We knew this all along. Okay? So the definition of a tangent is the opposite side divided by the adjacent. Now, it depends upon what angle you're looking at. Which side is the opposite and which one is the adjacent. The hypotenuse never changes. It's the one opposite the right angle. But if you're looking at this angle over here, this side is the opposite side, and this side is the adjacent side. Well, Mr. Greene, can't I just use the Pythagorean theorem to find these values? Why, sure you could, if you're given them. The whole point in trigonometry is we aren't always given all three sides. What if I was only given one side length and an angle? Could I find the others? Yes, you can. That's exactly what we're doing here. And as a matter of fact, that's how this problem came to be. Because if you want to know the truth, here is a castle sitting right here. Some Greek castle. And out here is some ship that the Trojans are getting ready to attack this castle. What the Greeks did was they set up a scout ship over here, a scout over here. They measured this distance here. They knew this distance, and then they would measure the angle that they saw the Roman ship out here, the Trojan ship, and then their catapults could fire their bullets, their little rocks that they would fire at the boats sitting out in the Mediterranean Sea to try to sink them. But they needed to know how far to fire them, and they knew how to set the catapults and everything. But they did that based upon this distance right here, where this person was right here. They measured this one. And they'd light a little flyer saying, okay, he's at 90 degrees here. And they'd say, okay, we know he's at this angle, set it at this, fire it, and they could sink the ship. And they were very accurate that way. That's where this came from. Let's look at some problems that we will be looking at. Here I'm given a 3, 4, 5 triangle. They're saying to find the tangent of angle B. Well, B is this one up here. And so the tangent is going to be the opposite divided by the adjacent. It's going to be 3 divided by 4. And that's all there's going to be to that. That's how that is done. 3 divided by 4. Okay? Now, can I use the tangent to find an angle? Why, yes, we can. We go backwards in this situation. So if I have the tangent of 30 degrees is 175 divided by 3.03, or this number. So the inverse tangent of this number is going to be 30 degrees. Okay, going back to this one over here. Could I find this angle B? The tangent of 30 degrees is 175 divided by 3.03, or this number. So the inverse tangent of this number is going to be 30 degrees. Okay, going back to this one over here. Could I find this angle B? Now that I know that this is 75 degrees, sure, I can go to the calculator and just type in tan inverse of 3 over 4, and it'll tell me what that angle B is, what that degree measurement is right there. And then do we know this degree measurement too? Yes, we do. Just because it's 180 minus 90 minus that angle. That's how easy these problems actually are to work. Okay? Now, they wanted to use the tangent to find an angle here. They're going to show us how to do that. If they wanted to find the tangent of 60 degrees, it would be 303 divided by 175. Going the other way around, if I took the inverse tangent of 1.731, I would find 60 degrees. Greene, how do you do that on the calculator? Because I want to be able to do this and solve some of these problems. Well, if you're looking at your calculator right here, you turn it on, you see this tangent? You see up here in yellow where it says tan inverse? So if I push tan inverse like that, and I type in there 1.73 205, just like that one that was right above it there, it should tell me 60 degrees. Well, pretty darn close to 60 degrees. I didn't type the whole thing in there. Let's try that other one. If I type the inverse sine of 0.5, I'm going to get 30 degrees. Cool? Okay, going back to the lesson here just for a second. So, the definition of a sine. If I'm trying to find the sine of angle A over here on the right, it is going to be the opposite side divided by the hypotenuse. Well, that's going to be fairly simple. Definition of a cosine. If I'm trying to find the cosine of angle A, it's going to be the adjacent side divided by the hypotenuse. Cool. So let's find each one of those. The sine of angle A is going to be A over C. The cosine of angle A is going to be B over C. The sine of angle B is going to be B over C. Oh, Mr. Greene, those are the same. Yes, they are. That's one of the interesting things about sine and cosine. Okay? The cosine of angle B is going to be A over C. These are equal, aren't they, Mr. Greene? Yes, it is. The sine and the cosine of opposite angles are going to be equal. Cool? So let's find this one. What is the sine of angle A? Well, it's going to be 16 divided by 20. I take the 4 out of that, and I get 4 over 5. What's the sine of angle B? It's going to be 12 over 20. It's 6 over 5. 6 over 10. Okay? How about this one? Cosine of angle A. Cosine of angle A is going to be 12 over 20. Divide the 2 out and I get 6 over 10 or 3 over 5. Cosine of angle B is going to be 16 over 20. Take the 4 out and I get 4 over 5. Cool. This works pretty good. Now I'm going to do an inverse sine here just to show you how it's done. It's the way the inverse tangents are done too. They say use the inverse function to find the measure of angle L. Okay? Well, L is here, and the angle that I'm looking at, here's L, and I've been given the side right here, and I've been given the hypotenuse down here. So that means I'm going to take 5.6 and I'm going to divide it by 8.54. They're going to move for me, okay? So I'm going to take pen, 5.66 divided by 8.54. That's what the cosine is. So if I want to find that angle, what I'm going to do using my calculator is I'm going to say second cosine 5.6 divided by 8.54 and press enter, and it's going to tell me the angle is at 49.02 degrees. And so I'd come back here to my problem, and it's going to be 49.02 degrees. Everyone see how I did that? Cool. So what we were doing is we were looking at problems, and they're saying 45, 45, 90, 30, 60, 90. We're using Pythagorean information. We're using trigonometry. And we're going to apply and justify a similar relationship, so that's what you do when you're doing trigonometry. Now, continue to keep working this week. The secret word for this week